Hello everyone, welcome to my U Programming Club. Today we will be solving another daily Leetcode challenge, and the challenge name is maximum running time of n computers. So the challenge statement is like this: you have given n computers and you are also given a zero indexed integer array batteries where ith battery can run a computer. Battery can run a computer equal to value of element at ith index in battery array. So you are interested in running all the n computers simultaneously using the given batteries. So what the problem statement is saying is, for example, let's take a sample input. Okay, the batteries array is given like this. This is the batteries array or batteries array, and number of computers given to us is 2. So say these are the indices of the battery array. Now the 0th battery would run a computer three minutes. It is nothing but the value of the element at the 0th index in the batteries array. I hope till now it's clear to you. Now let's move back to the problem statement. Initially you can insert at most one battery into each computer. So into each computer you can initially insert one battery. After that and at any integer time moment you can remove a battery from a computer and insert the battery any number of times. So what it's saying is, initially, let's say these are the computers. Initially each of them will be having one battery attached to them, and after that at any integer time moment, let's say this was at t is equal to 0. Now after any integer time moment, say t is equal to 1, 2, 3 or so on, it should be an integer. You can time moment should be an integer. You can remove the battery and insert another battery. Let's say this was the spare battery, and you decided to remove battery of the 0th computer. You removed it and inserted it. The insert battery can be totally new battery or a battery from another computer. Let's say this removed battery was used till here. Now you can what you can do is you can remove this battery and insert this battery here, used battery here. So it does not matter whether the inserted battery is a new battery or a old used one battery. And yeah, and we can assume that this insertion and removal of the battery from the computer takes no time. Okay, and it is to be noted that these batteries cannot be recharged. What it means is, whatever the capacity of the battery is given, it is final. It cannot be regained again by charging. Okay, and what we have to return is, we have to return the maximum number of minutes that we can run all the computers simultaneously. So initially there were two computers, and we are asked what is the maximum number of minutes Using these batteries, these computers can run together. So how will we doing this problem? If you what is the max If you observe, what is the maximum number of hours a computer can get? Again, yeah, it's fine now. Still it's lagging. Let me quickly resume the pause the recording, and then okay, it's or let's take a new slide only. I think here it will not cause any issue. Yeah, here it's fine. It's fine here. Okay, I don't know what caused that issue. Also, let me quickly revert back to the original settings. Sorry for the technical glitch. Yeah, what were we discussing? So how will we be approaching this problem? So the given input was 33333, and what is the maximum number of hours if there were a single computer? How many hours this can run? It can, let's say there are n computers, not a single one. Let's say there are n computers. How many number of hours? How many? Not hours, it's minutes. How many minutes each one can run at max? At max, they can run sum of batteries array divided by number of computers, which is n. At max, each computer can run this much time. And what is the minimum time it can run? It is 0. If you don't decide to run any computer, it will be 0. So from 0 to this number, it is the range, the number of hours computers can run simultaneously. So if you decide to try out every possible value in the range and check whether we can run n computers, or let's say you selected a number with t minutes in this range, t minutes in from this range. Whether we can run the n computers for t minutes. Let's say this is the approach you will be taking, and this will be the brute force approach. Okay, so the brute force approach will be this, and now let's look at the constraints. So the battery's length is of the order 10 raised to power 5 and the values of batteries is of the order 10 raised to power 9. So this sum of batteries will be 10 raised to power 5 into 10 raised to power 9, and since n can be at max 10 raised to power 5, so at least this much values are available to you from 0 to 10 raised to power 9, and which is order of 10 raised to power 9, and it is greater than order of 10 raised to power 8. So these are the operations allowed in 1 second. So for those of you who do not know, let me quickly change the slide. So for those of you who do not know how the accepted solutions time complexity varies according to input size, I will be providing a link of a article describing this, so you can have a look. At present I can tell that this 10 raised to power 9 operations are greater than 10 raised to power 8 operations allowed in 1 second. So it will definitely give you clearly that brute force approach. What is the brute force approach? This is the brute force approach, checking from 0 to the maximum possible value. This is the maximum possible value for a computer to run with all other computers given. So and here is the number of computers. A single computer can run this much maximum minutes along with other computers. So if you check every value in this range and check if it's the correct value or not, it will give you TLE. Now you have to, what you have to do is you have to optimize this approach. Optimize. So you cannot change this part where you check whether we can run n computers for t minutes. It cannot be changed, since you would be checking this value, or how else you will be know that if your value that you selected, let's say you selected 10 minutes, and if all computers can run simultaneously for 10 minutes, you cannot change this part. So what you can change is you can change the selection of the t, selection of value in this range. If somehow you are able to reduce the time complexity of the selection of value in this range, then you will get a accepted solution. So what we will be doing is, since all the values between 0 to this maximum value, max minutes value, are in increasing order, and they are sorted, so we can apply binary search. What we are applying binary search on, this is the trickier part. This is where the crux of the logic is. You have to apply binary search on selection of, let's say you selected t minutes, selection of t minutes from 0 to max possible minutes of simultaneous running of n computers. In this range, for t's value, you will be applying binary search. And since the time complexity of the binary search is, let's say n is the input size, time complexity is order of log n, and n here is 10 raised to power 9. So for checking t's value, you will be doing at max 10 raised to power 5 operation, since this is the size of the batteries array, maximum size. And what it will be, then for each value we will be applying binary search, so it will be order of log of n or log of 10 raised to power 9. So the time complexity will be like this, and since it will be lesser than 10 raised to power 8 operations, so your solution will get accepted, you will get IAC. So let's move to the coding part. There I will be showing you how binary search will be applied on this range. Let me quickly move to the coding part. So what we have done is, we have first sorted the batteries array. Why we have sorted, you may ask? Because if let's say the values in the batteries array are given like this, again the same problem is occurring. Let's change the slide only. If the values are given like this, let's say this is 5 1 3 7 6 8 9 1 1 1 1. So to get to the optimal number of computers, in 3 minutes we are doing sorting. This unorganized array or unorganized batteries array would not give us the optimal number of computers that you can run in 10 minutes. So that's why we are doing the sorting. Hope it's clear to you. If you are not still not clear with this, you can just comment this for a second and try on your own. You will get a wrong answer, and then you can have a try run with that wrong answer. Then you will be able to understand in a more clearer way. I also did the same. Actually, I knew that this sorting is necessary, but just to prove myself right, I just commented it out, and I just have a run with the commented solution, and it is necessary. So what I mean to say is, it's necessary to get the optimal number of computers. So first we'll be doing the sorting part, and then this is the function where we are applying the binary search. I will also mention this is to get the optimal number of computers we can run together in 3 minutes, 40 minutes. Okay, and this is the binary search part. Search for the value of t in range 0 to max. Let's call the number of minutes each computer and simultaneously runtime RT, runtime, max runtime for each computer and simultaneously. Sorry if the spelling of some spelling is incorrect. I have misspelled something. I hope it does not affect the way you are understanding the solution. Now let's quickly move to the main logic of the problem. These two functions are having the main logic of the problem. So this is a standard binary search. This is the least value possible for runtime, least value possible for running simultaneously, value of time. And this is the maximum value possible, the maximum max value of time possible for simultaneous running. Till now I think it is clear to you. It is this range that we have discussed about, sum of batteries divided by number of computers. Maximum value a single computer can run together with all the computers. So this is a standard binary search. The trickier part in the binary search lies here. How will half our range in binary search? Basically, according to some given condition, we half our search space. The trickier part is, this is the trickier part. So we will reduce our search space. So we have created a test run function. This is the current, mid is current selected value in the range computed above. So how will be doing this test run? What we'll be doing is, this is the proposed range. What it is current choice of runtime, and these are the number of computers given to you, and let's say the current number of computers, computer count is initially 0 and current runtime is also 0. We'll iterate over the batteries array once, iterate over the battery array once. So if the current runtime happens to be greater than or equal to the proposed runtime, then we will subtract the proposed runtime from the current runtime. Why we are not declaring the current runtime entirely 0? Because we can reuse unfinished batteries. So we'll increase the computer count, and at last we will check whether the computer count is greater than or equal to the number of computers given. If that's the case, we'll return true, otherwise false. And based on this condition, if this condition holds true, means you can at least run computers t minutes or say mid minutes together. If this is true, if condition true, you can run these computers t minutes together. Then what you will be doing is you will be checking for this is mid minutes. You will be you will shorten your range, and you will shift the minimum value of the range to mid plus 1 minutes. And else if it's not sufficient, if it's a very larger time we have taken and computers cannot run this much minutes, mid number of minutes together, so we'll reduce our search space, and at last we'll return the answer, which is the maximum runtime possible. Initially we have taken the maximum runtime 0. So yeah, this wraps up the solution of the problem. Thank you for watching. Thank you.